Hello everyone, I Akash Nath welcome you to the ELL101 project. In this project, I am going to discuss the latch circuit demonstration. Now, what is a latch circuit? Basically, the word latch means to become fixed in a particular state. In electronics, latch circuit is a circuit which locks its output when a momentarily input trigger signal is applied and retains that state even after the input signal is removed. The state will remain indefinitely under the power is reset or some external signal is applied. Latch circuit can be very useful in alarms where a small trigger signal will turn on the alarm for indefinite period until it is reset manually. Now coming to the components of the latch circuit, we will have two 10 kilo ohm resistors, two 100 kilo ohm resistors and one 220 ohm resistor. The transistors namely BC547 and BC557, one capacitor of 1 microfarad, a relay of 6 volt, a diode namely 1N4148, LED, and a power source which varies between 5 volt and 12 volt. Before going into the explanation, I would like to make a note that transistor Q1, that is BC547, is an NPN transistor which turns on when a small positive voltage is applied to its base, and transistor BC557 is a PNP transistor which turns on when a negative voltage or ground is applied to its base. Next, I would like to make a note about relay. Relay is an electromagnetic switch which is controlled by a small current and used to switch on and off relatively much larger current. This means by applying small current we can switch on the relay which allows much larger current to flow. Relay is a good example of controlling the AC devices using a much smaller DC current. Now coming to the explanation part, initially both the transistors are in off state and relay is deactivated. PNP transistor Q2's base is connected to positive voltage with current limiting resistor R3 so that it won't conduct accidentally. Capacitor C1, as you can see in the diagram, has been used as a precautionary to prevent the accidental and false triggering of circuit. Now, when a small positive voltage is applied to the base of the transistor Q1, that means in this part, it turns on the transistor and base of the transistor Q2 gets connected to the ground. That means this part. Resistor R2 and R3 prevents the short circuit in this condition. Now the base of the transistor Q2 gets grounded. It starts conducting and energizes the coil of the relay. That means this part, which activates the relay and turns on the device connected to the relay. In our case, the LED, that means this LED will glow. This is a normal behavior until now, but let's see what makes it a latch circuit. If you notice, collector of transistor Q2, that means in this part, is connected to the base of the transistor Q1 through a current limiting resistor R4, that means through this path. And when the transistor Q2 turns on, current flow in two directions, first to the relay and second to the base of the transistor Q1. So this feedback voltage to the base of the transistor Q1 keeps the transistor Q1 on for an indefinite period, even after the input voltage is removed. This in turn keeps the second transistor on indefinitely and a latch or lock is formed instantly. Now the alarm or the device connected to the relay will remain on until the power is reset, or a reset push button can be added to this circuit to break the latch state. This button would connect the base of the transistor Q1 to the ground, which turns off the Q1 and Q2 transistors and break the latch. Now, if we don't want to latch any AC appliances and just want to turn on the LED or a buzzer, we can simply remove the relay and connect LED directly in place of relay with a resistor. Now, coming to the part of the functionality of the diode in the circuit, that means this diode D1, which is known as 1N4148. It is used to prevent reverse current flow when a transistor is switched off. Every inductor coil in relay produces equal and opposite EMF when switched off suddenly. This may cause permanent damage to the components, so diode must be used to prevent reverse current. So here we come to an end of the demonstration of the latch circuit. Thank you very much.